Hey everybody, so today we're talking about real nth roots of an integer. Okay, so we'll start off by going over some of the typical properties of roots. So if your n is odd, then a has one real root. So looking at this a little more closely, okay, let's say we're taking the cubed root of 8, correct? Okay, that can also be written as 8 to the 1/3 power. Okay, either way, it means the same thing. But we know that the cubed root of 8 is positive 2. Okay, the reason it is positive 2 is, and not plus or minus 2, is because 2 times 2 times 2 I know is 8. Now, negative 2 times negative 2 times negative 2, well, that equals negative 8. So negative 2 is not an option as an answer. The only answer could possibly be positive 2, and that's why they state that if n is odd, then a has one real nth root. Okay, it's just got that one number. Whereas if n is even, okay, then a has two real nth roots. And what it means by that is, like, let's say we're taking the square root of 49. Okay, you could also, again, this could be written as 49 to the 1/2 power. Okay, either way, we know the square root of 49 is plus or minus 7. The reason we put the plus or minus sign is because positive 7 times positive 7 equals 49. But negative 7 times negative 7 also equals 49. So it could be plus or minus 7 when you're looking for that square root of 49. Okay? Some other slightly more obvious properties: the square root of 0, any root of 0 is always going to be 0, okay? And then if you have a square root or a fourth root, any even root, and your a is less than 0, then there are no real nth roots. So that's saying something like the square root of negative 9, okay? There's nothing that multiplies to negative 9. Okay, 3 times positive 3 times positive 3 is positive 9. Negative 3 times negative 3 is positive 9. There is no combination that will multiply to negative 9, so you have no real roots in this case. When you move on to Algebra 2, you'll talk about imaginary numbers. We are not going to touch on that in this class, okay? Again, all right, there are different ways to express certain things. So if you have something like 27 to the 2/3 power, okay, what that means, the top number, okay, this top number here is your exponent, okay? The bottom number is actually a fraction, which would make it your root, okay? So whenever you're evaluating something like this, okay, remember it's in the parentheses first. The cubed root of 27 is 3, and then we can square it to get an answer of 9, okay? I think it's time we do a little bit of practice, okay? So let's look at this. It says, find the indicated real nth roots of a. So the first part is the setup. I am going to have you write your answer in 2 different ways. I'm going to change out of this red color because I don't like it. Pink. All right. So we're taking the nth root of a. So that means the second root of 64. Okay. The other way we could write this is 64 to the 1/2 power. Okay, either way, I know that the square root of 64 is plus or minus 8. All right, and when you're doing something like this on a test, I would be looking for all 3 steps, okay? So this whole thing would be your answer, because I want to know you know how to represent it in these 2 different ways and that you know how to evaluate it here, okay? So number 2, okay, we're taking the nth root of a, so the third root of 27. So that would be the third root of 27. Represented as a fractional exponent would be 27 to the 1/3 power. Okay, the third root of 27 I know is 3. So this whole thing is my answer. Okay, again, if you're catching on and you feel confident, I strongly, strongly urge you to try these on your own. Pause the video, try the number 3 on your own, and then watch number 3. Okay, so the nth root of a, so the 4th root of 256, or 256 to the 1/4 power. The 4th root of 256, okay, it's an even root, so it's going to be plus or minus, okay, and the 4th root of 256 is actually 4. So this whole thing is our answer in this case. Okay, so far so good, I'm hoping. Number 4, okay, we're going to be taking the 5th root of 243, written as an exponent, would be 243 to the 1/5 power, okay? And the 5th root of 243 is actually going to be positive 3, okay? Notice, I hope you're noticing that on our even roots, we're having this plus or minus, right? And the odd roots, we don't get that plus or minus, okay? And the even roots, again, they're going to have 2 answers, while the odd roots do not, okay? So, the 8th root of 256 can also be written as 256 to the 1/8 power, all right? And the 8th root of 256 is plus or minus, because it's an even exponent, 2, okay? Now, if you're trying to plug these into your calculator, okay, it's probably easiest for you to plug them in this way, okay? So when you do plug them in, you should have something like 256, make sure you have your parentheses, and then you put a caret, and then again, parenthesis 1/8, okay? This is how it should look in the calculator. Okay, there is a way to enter it as a root symbol. Okay, there is that way to enter it as this root symbol. However, that can get a little complicated. I want to wait till I'm actually in class to be able to show you guys. All right, so last we have the 4th root of 10,000. Oop. Okay, so that's the same as saying 10,000 to the 1/4 power. And the 4th root of 10,000, that's going to be a plus or minus, because it's an even root, 10. Okay? All right. So, they want us to evaluate the expression. Okay? I still want you to write it, if you can, as a in the other form. So if it's in radical form, we're going to write it as a fraction. As a fractional exponent, if it's a fractional exponent, we'll write it as a radical. So the 4th root of 625, that can be rewritten as 625 to the 1/4 power. Okay, and when you write it that way, it's easier to enter it into your calculator. You should be able to get the fourth root of 625 to be plus or minus 5, okay? Number 8 is the cubed root of negative 512, also rewritten as parenthesis negative 512 to the 1/3 power. Don't forget those parentheses, they are so important, okay? And the third root of 512 is actually negative 512, I'm sorry, is going to be negative 8, okay? It's not plus or minus, it's not just positive, it is negative 8. Okay, the cubed root of negative 216 can be rewritten as parenthesis negative 216 to the 1/3 power. The cubed root of negative 216 actually comes out to be negative 6. All right. Number 10, I know this seems repetitive and easy. However, I do want you guys to get familiar with working with the calculator, okay? So, number 10, the fifth root of negative 243, also known as negative 243 to the 1/5 power, okay? The fifth root of negative 243 comes out to be negative 3. Okay, again, I don't expect you to know these. You should be using a calculator at this point. Okay, 729 to the 1/6 power, that can be rewritten as the sixth root of 729. And I know that the sixth root of 729, since it's the sixth root, it's plus or minus. That's going to be 3. Okay. All right, and negative 81 to the 1/2 power, if you check this out, that's going to be rewritten as the square root of negative 81. And if you remember from before, okay, you cannot take the even root of a negative number, so that comes out to no real solutions. All right. Okay, so 13 through 15 says rewrite the expression in rational exponent form. Okay, if you remember from up here, your top number is your exponent, your bottom number is your root. So when we're rewriting these in rational exponent form, okay, I keep the same base. Okay, my top number is my exponent, my bottom number is my root. Okay, same thing here. All right, rewriting this, it becomes negative 8 to the top number is my exponent, 2. My bottom number is my root. This one's actually quite easy to evaluate. The cubed root of negative 8 is actually going to be negative 2 squared. Okay, and negative 2 squared I know is positive 4. That's just a little extra on the side. Okay, number 15 can be rewritten as 15 to the 7/4 power. Okay, again, you want to put your exponent on top, your root on the bottom. Okay, and 16 through 18, we're going to be doing the reverse. So this can be rewritten as the fifth root of negative 3 squared. Okay. Number 17 can be rewritten as the square root of 6 cubed. Okay. Exponent on top, radical on the bottom. And number 18 can be rewritten as the fourth root of 12 cubed. I'm not going to ask you to evaluate any of those. They're a bit tricky. All right, but this last part wants you to evaluate each expression. So if we convert this, it's going to be easier. So if you convert this to the 5th root of 32 squared, okay, the 5th root of 32 is actually easier to evaluate. If you're using a calculator, you might want to enter it as 32 to the 1/5 power squared, or you could enter it just like this. But either way, however you choose to enter it, the 5th root of 32 squared is going to give you an answer of positive 4. Okay? Negative 64 to the 3/2 power, that's going to be the square root of negative 64 cubed. We can't take the square root of a negative number, so right away that tells us there are no real solutions. Okay. 25 is 256, or 22, I'm sorry, is 256 to the 7/8 power. So that's the 8th root of 256 to the 7th power. Okay. Or you could also write it as 256 to the 1/8 power to the 7th power. Either way, once you enter it into your calculator, you should be getting an answer of 128. Okay. 23. Okay. That's going to be the 6th root of negative 729 squared, or to the 5th power, I'm sorry. To the 5th power. And when you have the even root of a negative number, you should know right away there are no real solutions. Okay? Oh, I missed 21 and 24. My apologies. Okay? 21 can be written as the cubed root of 343 squared. Okay? Or 343 to the 1/3 power squared. Either way, you're going to need a calculator. All right? And the cubed root of 343 squared should come out to be 49. Okay. The 4th root of negative 625 cubed, we're on number 24 now. Sorry about skipping around there like that. The 4th root of negative 625, well, I can't take the 4th root of a negative number, even root negative number, so that is no real solutions. Okay, and that is the end of chapter 6.2. All right, 6.3 is next.